Let's consider example when x equals to cosine t, y equals to sine t, t is between 0 and 2 pi. One more time. Often when we look at the parametric equations, we think that parameter t is time, and x and y are coordinates of a point on the xy plane. So when time progresses, the point moves on xy plane. So if you recall what is going on, so you remember what is going on. So point starts at t equals to 0 when x equals to 1, y equals to 0. Then it moves toward point t equals to pi over 2, y equals to 1, x equals to 0. Then it moves to point x equals to negative 1, y equals to 0. That's when t equals to pi. Then it goes to point t equals to 3 pi over 2. Then it moves back to a point where it started at t equals to pi. So we can describe the curve as a movement over particle. So we can say that particle moves circle, unit circle, squared plus y squared equals to 1, moves counterclockwise. I want to say where it's starting. X equals to 1, y equals to 0 when t equals to 0. It's rotation back to where it started 1, 0 at t. It started at t equals to 2 pi. So we can illustrate that by picture. We also can provide some wording to it. Let's consider the following example. We have a curve y equals secant squared t, x equals a tangent t. T is between 0 and pi over 2. And we have a position of a particle given by the parametric curve, the parametric function, and we want to describe the movement of that particle. So first we notice that we have secant and secant squared and tangent. So we recall how secant squared and tangent squared relates. So secant squared equals to tangent squared plus 1. So from here we're going to get y equals to x squared plus 1. So from here we're going to get a parabola y equals x squared plus 1. Which looks like this. Okay, now we want to describe what is going on at point when t is between 0 and pi. Firstly, we investigate what is going on initially. So what is going on when t equals to 0? When t equals to 0, y equals to secant of 0 is 1. And x equals to tangent of 0 is 0. So when t equals to 0, that's where we start. Now, so if we try to plug in the upper bound pi over 2, we're going to get secant squared of pi over 2, but that is going to be undefined. So what we can do is we can notice that when t equals to pi over 2, x is going to be tangent of pi over 2. And that's going to be undefined. The same, we're going to get y equals to secant squared of pi over 2, which is also undefined. So that is a bit confusing. So let's try to figure out what is going on. Let's look at the graph of x, which is tangent of t. Can graph x is a function on t, and our graph is going to look something like that. We recall what the graph of tangent looks like. X is dependent variable, t is independent. Notice that t is supposed to be between 0 and pi over 2. So t equals to 0 here, and t is equals to pi over 2 is right there. So when we try to reach that pi over 2, when t is reaching pi over 2 from the left, what is going on? We see what's happening. The fact x is approaching plus infinity. So when t is approaching pi over 2, x approaching plus infinity. So keep that in mind. We are ready to answer our question. When t is approaching pi over 2, so when t is approaching pi over 2, x should be approaching infinity, so x should be approaching infinity, and x in our original graph is horizontal, so that's the curve we're talking about. That's the part of the curve. And that's going to be our answer for this particular